Let's talk about homophily and the ripple effects of events. These are two patterns that we can discern across a network. Homophily is a principle that says social contact between any two similar people is much more likely than social contact between any two dissimilar people. If we're alike, we're much more likely to interact. If we're different, we're much more likely not to interact. This is a probability of 2 nodes. As we'll see when we take a look at the entire network, sometimes we see something different. But let's stick with the definition there. Homophily can be observed on just about any socially meaningful trait. Not toenail length. Not whether our belly button is an innie or an outie. These are things that we don't notice. These are things that we don't use to make distinctions in our society. But most physical traits or social traits that are not physical, religion, ethnic history, those are all dimensions along which homophily can be said to exist. Let's talk about an example, perhaps the simplest one. We have a trait which is where we are, our location. We can think about geographic homophily, and we can say that interactions between people who are very different in their location, people who are living far from each other, will occur far less often than chance would predict, and that interaction between people living close to each other who have similar locations will occur more often than chance would predict. Now, why would this be? There are 2 arguments about why homophily exists. The first one is the one that most people jump to, as is the case in most social trends, which is, oh, people must want that to happen. It must be a choice that people make. The idea is that if you're surrounded by a bunch of people, and as we are on the earth, and you are going to choose who to interact with, that you will have a preference for those who are like you. Now, that doesn't quite make sense for us intuitively when it comes to geographic homophily, because we think right away, well, that's ridiculous. Sometimes we're far away from people, and we never even know about them because we never see them. We just bump into people who are close by, and we form ties. That kind of explanation is an explanation based on constraint. You're constrained in getting to know people based on physical distance. That is an induced homophily. Induced means it's forced on you from the outside. Now, that might not necessarily have to be true now that we have telephones and internet and letters and things like that. But let's find out, is it? There's a fellow named George Zipf who in the middle of the 20th century studied this, and he wrote a great book which I suggest you read if you're into the idea of the frequency of events and the difficulty of bringing those events to pass. His book was called Human Behavior and the Principle of Least Effort. And if you are a physics student, you will take a look at this equation and you'll see something equals g times population of 1 times population of 2 divided by the distance between 1 and 2 squared. What else do we have that divides by the distance between 1 and 2 squared when we come up with an equation? Gravity. Population of any 2 places, which is the number of people there, can be thought of as mass. Population mass. The population mass of a place like Augusta, Maine is about 25,000. The population mass of New York City is a few million. What's he saying here? Well, g is some constant, just some number. He's saying that when you have 2 cities and they both have large populations, then p, the probability of interaction between those 2 cities, goes up, because there are more people to be interacting. He also says that as the distance between community 1 and community 2 goes up, that the probability of interaction between those two will go down. That's because it's in the denominator. You're dividing by the distance. So as distance gets bigger, p gets smaller. As the population sizes of those places get bigger, the likelihood of interaction becomes greater. Okay? This is a gravity model. The contention of homophily is a contention that we have a social fact of social gravity in social networks, which is pretty cool. And what's really cool is that George Zipf went out and studied these things. These are actual figures from his book. Let's take a look at his figure 920. Over on the left-hand side, you will see the estimated average haul in hundreds of miles. Okay, has a y-axis, and the pounds hauled on the x-axis. What's that saying? Okay, the miles hauled is how far the railway went. This is in May 1939, a long time ago. Okay, how long was it hauled? Well, and then how many pounds were hauled in 1939? Okay, the hauls that covered long distances, that's high up in the graph, didn't sum up to much in terms of pounds. The hauls that had short distances added up to hundreds of thousands of pounds. What does this mean? It means more is hauled over shorter distances. Much less is hauled over long distances. What's a railway haul? It's a connection between two places. More connections happen over shorter distances. Figure 920b over on the right. The estimated distribution of toll messages. This is by AT&T. This is phone calls in 1948. In October 1948. What do we find? The number of messages that travel a long way is lower. If you look at the number of messages, only 100 messages in the lower line, you see a dot there? Only 100 messages go about 2,000 miles. But it's a logarithmic scale on the x-axis. If you look over on the right, at line B, you'll find some dots there that are telling you that way over 10,000 messages, phone messages, traveled just between 100 and 300 miles. It turns out that there's geographic homophily. Bottom line, there are more phone messages that go shorter distances, far more. There are fewer phone messages that go longer distances, far fewer. It looks like people interact more, even over the phone, with those who are close by. Last semester, I asked students in an Introduction to Sociology class to tell me the state that they were born in. What state were they born in? Overwhelmingly Maine. Next most likely was this ring of New York, Pennsylvania, Virginia, a little far away, and then a whole bunch of empty states with no numbers in them at all. There is a proximity between where a person has been born and when they go to college. How can we think of that in terms of social ties? We can think about it in terms of moves. People move to places nearby. They are the tie. They are the thing that's communicated from town to town. From town to town, fewer people are communicated if the towns are distant. More people are communicated from town to town when the communities are close. So that over the lifetime of most Introduction to Sociology students, they stay within the state. We can get more detail on this thanks to Greg LaPointe, the Director of Institutional Research at the University of Maine at Augusta, who has studied the top 20 high schools, okay, in terms of the number of students they supplied for enrolled students at UMA in the fall of 2011. You can look at the list here. We can put them on a map. What do you see? Well, we're the University of Maine at Augusta, and there are a lot of schools that are centered around Augusta. There are some that are centered around Bangor. And what do we have? Our secondary campus is UMA Bangor. There are a few more that are centered around Rockland. I can tell you that the University College at Rockland, which is a UMA affiliate, and where UMA classes are taught, is the largest affiliate location in the state of Maine for the University of Maine at Augusta. Bath comes in just underneath that level. This is geographic homophily. Where people went to high school, where people go to take university classes. It's a short distance. The nodes in this case are the communities, and the communication again is the person. A community sends a person to another community, or a community sends a person, in this case, to a university. Let's go back to ZIP. We can take a look at the length of one-way trips in miles by trucks and passenger cars. This is again in the 1940s. And we can look at the number of trips that are taken. This is actual data that was collected, and what each dot tells us, okay, is some combination of the number of trips that were taken and the length of the trips. The trips, looking up the y-axis, the trips that are longest, like 1,000 miles in this period, didn't happen very often. The number of them is like 10. The trips that took about 100 miles, well, there were about 1,000 of them in this study. The trips that took 10 miles, about 100,000 of them. The trips that took 5 miles, it looks like about, on this logarithmic scale, about, maybe 500,000. There are many more trips that are short than are long. So, again, this is the communication between two nodes, two communities, the origin and the destination in your trip. The person is being communicated, and geographic homophily is in force. Here's another one, marriage licenses. Now this is a social tie between two people, right? Which people are going to get married to each other? Okay, this is 1931. It's Philadelphia. It's data from 5,000 pairs of applicants for a marriage license. And in the marriage license application, you have to specify, my name is Joe Blow, and I come from the town of blank. My name is Jane Davis, and I come from the town of blank. And here's my address. And now most of these people lived in Philadelphia, but when they specified their address, okay, H.S. Bossard, and then ZIP taking Bossard's data, are able to say how many blocks away are the two lovebirds that are getting married. Great. It turns out that when the distance in blocks is low, just 1 or 2, that dot in the upper left, there are a lot of those kinds of marriages. If we talk about going up to a distance of 5 blocks, there are fewer of those marriages. And if we talk about going up to a distance of, say, 20 blocks or so, there are many fewer of those marriages. We like to think that there is one perfect person for us. Isn't it convenient that that one perfect person for us tends to live in just a couple blocks away? And that those imperfect people that just aren't for us, that one special person, they tend to live in blocks that are farther away? Well, that's one theory. That might explain it. The other theory is that there isn't just one special person for us, and the people we bump into in an induced homophily, based on the constraint of distance, determines who we pick. We pick those we bump into, and we bump into those who are close. our social networks are geographically constrained. Charge accounts. This is cool. Okay, and this is again in the same period, 1930s, 1940s. Now he's put distance on the bottom. So, okay, you're going to see the trend reversed, but you notice distance is no longer essentially in the numerator, it's in the denominator. So as distance increases, the population size divided by distance will decline. Okay, so it's a little counterintuitive, but the basic idea of this chart is that, how many people are getting charge accounts with Jordan Marsh Company in Boston, and how distant is their community in 96 cities and towns in Massachusetts, New Hampshire, and Maine. How distant is it from Boston? Okay, so each of those dots is a city or town in Massachusetts, New Hampshire, or Maine. Each of those communities has a distance from Boston. And then we can see, well, how many charge accounts are there with Jordan Marsh Company in Boston? Okay, as distance increases, which means that P over D goes down, you have fewer charge accounts. Most of the charge accounts are happening where distance is small, and therefore P divided by D is large. Geographic homophily. It occurs again and again. It's starting to look like a general social law, isn't it? Same trend here. Bus passengers between 29 cities during intervals of measurement in 1933 and 1934, which is why there are more than 29 dots. Again, now notice, this is two population centers divided by distance, so it's the inverse of the effect. You see the effect if you take a look at this chart in more detail, that most passengers travel small distances. Many fewer passengers travel long distances. How about this? Newspapers. The number of different news items in the Chicago Tribune with a date line mentioning a particular city. You'll notice this in the newspaper. Read one of them sometime. They're great things. They'll start off, June 20, 2012, Boston, Massachusetts, or, September 7th, 2012, Baltimore, Maryland. And the date line there that gives the date and then the name of the city tells you what the article's about. It's about something that happened in Boston, or it's about something that happened in Baltimore. Okay, well, the Chicago Tribune is a newspaper that's in Chicago in the 1930s and 40s here. And again, we've got the inverse of distance here, so it's kind of the opposite effect. You've got to flip it in your mind. As distance goes up, and therefore as that figure P1 times P2 divided by D goes down, there are fewer news items mentioning that distant city, okay, in the Chicago Tribune. What about close by cities? Well, they're mentioned more often. What is that? It's a social tie. It's a network connection between two towns, and the connection is a mention in a newspaper. All connections between Chicago and other towns. They put a W up there, and that's the date line for Washington, D.C. That has a huge number of items, even though it's kind of in the middle in terms of distance from Chicago, which if you look on a map, Washington, D.C. is. That is a special case. It's an outlier, and that's because Washington, D.C. is our nation's capital. And so there are a lot of stories about the nation's capital. But otherwise, the trend follows. We can update ZIP. Okay, that stuff was, a long time ago. 80 years ago, 70 years ago. But this study, called Urban Gravity, a Model for Intercity Telecommunication Flows, looks at telephone calls in Belgium on your mobile phone. How long is the call? That's an indication of the strength of the tie, right? If it's a short call, it's just, whatever. It's a long call in terms of seconds. 10 to the 6 seconds? Wow. Okay. That is a significant contact. That's like, you're talking to your best friend, you're talking to your mate. Well, it turns out that the longest calls are occurring over the shortest distance in kilometers. The shortest calls are happening over the longest distances in kilometers. It's not just that we are less likely to have a contact with someone at a distance, it's that the contact is more likely to be fleeting. Here's a map of what's going on in Belgium, which is really cool. Each line represents the existence of a phone call from one community to another. The brightness of the line and thickness of the line is an indication of how much communication happens. Now you can see two things happening here. First of all, you can see all these little stars, right? These little sociometric stars, which is what they call them. And those little local stars are basically saying, hey, here's a town, and here's a bright burst of local phone call activity. Very local, very small. Then you see a few bright streaks really shooting across the country of Belgium. And what is that telling you? Those few bright streaks are between places where there's a lot of people. So that, yes, it's distant, but there's so many people in Liège and Brussels, for instance, that there's going to be a lot of communication between them. So, the probability that any two people in Brussels and Liège are going to communicate is much lower than the probability that two people within Liège, or Liège in a suburb, are going to communicate. But there are just so many people to do it in Brussels and Liège that there's this huge volume of it anyway. This is geographic homophily. 1971, a study of supermarket drawing power. This is business, man. This is economics. And this is a study of the probability of patronizing a store, going to a store, buying things. Okay. We have a few lines there, right? You have lines that say, hey, there's competition within a mile. Hey, there's a freestanding neighborhood here. Or, hey, this is the community shopping center. It doesn't matter. Those are all contextual variables. The pattern is the same. The greater the distance from a person's home to the supermarket, the less likely they are to patronize that supermarket, to go to it and shop there. That's geographic homophily. This one's really interesting, okay? The title of the paper is called Space-Time Dynamics of Insurgent Activity in Iraq. The authors are Townsley, Johnson, and Radcliffe. What you have here are three maps of space. And if you look carefully, okay, at the units down in A, then the units of distance in B, and the units of distance in C, you'll see that it's like a zoom out is going on from A to C. The units of distance in A are just 0 to 5 kilometers. In B, from 0 to 20 kilometers. And in C, from 0 to 200 kilometers. That's the x-axis. The y-axis is the number of the number of days that have passed from the initial event. There's an initial IED attack, improvised explosive device attack, that happens. And these authors then study, well, is there a spread of insurgent activity? That's something that flows through networks. Okay. Insurgent networks set off a bomb one place. Where are they going to do it next? It's travel over space. And what you find is that there is a strong, dark areas, a very strong tendency for attacks to occur close by in the early days. and then as time goes on, for attacks to occur more distant. So that if you look at over at C, the farthest distance, okay, these attacks begin to occur over the longest stretch of days, up to 40 days. Two ideas. First of all, a second attack is most likely to happen close by to the first attack. Second idea, the insurgency in Iraq spread. The use of IEDs spread. It spread over space, but it took a lot of time to do that. Here's an interesting dimension of social life, education. And we can talk about homogamy, which is a kind of homophily, but the suffix gamy refers to marriage. So educational homogamy means you marry someone who is in the same category of educational attainment as you. Did you finish high school? Did you do some college? Did you graduate from college? Did you not graduate from high school? What do we see here? We see that women and men in recent years have been consistently marrying people who are in the same category that they are in. We can look at this for different countries. Now we can talk about hypogamy, which means you marry people less educated than you. Hypergamy, you marry people that are more educated than you. And homogamy, you marry people with the same level of education. In ES, which stands for Spain, in Denmark, in China, in the United Kingdom, in France, in Sweden, the biggest category by far is homogamy. People choose or end up with marriage partners who have the same level of education that they do. Does homophily mean necessarily that members of some groups will always interact mostly with members of their own group? No, not if the group sizes are very small. This is important because we have some groups in our society that are very small. For instance, people who are members of the Muslim or Jewish religions. People who have PhDs in biological anthropology. These are small groups, and because they're small groups, they have very little option but to engage in some social contact outside their group, and certainly at a rate that's higher than with larger groups. To see why, take a look at this example brought up by Peter Blau. Let's assume that there are groups of people. There are the whites and the reds. Now, at some point, there's going to be some connection between them. Someone's going to put up a tie. Well, what's the rate of association? What's the rate of tie formation? It depends on your denominator. There's one tie, right? But for reds, it's one out of the two reds that's doing it, okay? That's engaged in that tie. There are four whites over on the right. And so there's one tie to a red out of four whites. 1 out of 2 for reds, 1 out of 4 for whites. 1/2 is bigger than 1/4. Half of the reds are interacting with those outside their group. 1/4 of the whites are interacting with those outside their group. The rate of intergroup contact is bigger for smaller groups. You could try to fix this by making more of those ties, but every time you did, you'd still have to divide by just 2 for the reds, but you divide by 4 for the whites. No matter how many ties you draw, or no matter how few ties you draw, as long as there are some ties between the groups, and in any society there are going to be some, the rate of intergroup contact will be larger for smaller groups, even when homophily comes into play. What does this mean? Well, Peter Blau thought about homophily existing, number one, but also about the numbers of people in a population. And he said, well, we can think about this in a multidimensional way. That multidimensional space is called Blau space often. And what is it really? It's the idea that an education age space, like in this graph, right? It's just a graph with an x and a y axis. It creates a space that is just as real as geographic distance. And the number of people in any one spot or in any other spot in this Blau space determines how much contact there's going to be between people in those two positions. Homophily comes into play. These are results from the GSS, the General Social Survey, 1985, in which people were asked to describe those with whom they discussed important matters. For people who are 30 years old with 12 years of education, there's a dark area. Dark means more, a higher probability of interaction. Okay. Well, sure, they'll interact with people who are more like themselves, but there are a lot of people out there that are older. So you'll notice there's some association in that direction. The existence of large numbers of people who are older means that there are going to be some people, a 30-year-old with 12 years of education, are going to know who are older. This tendency becomes a lot more pronounced when you consider a 90-year-old with 4 years of education. Now, how common is a 90-year-old with 4 years of education? It's not that common. So you'll notice for such a person that there's a little peak where they are. Low education, high age. But that there are so many people that are far away in this Blau space. A higher level of education, high school graduates, younger age, that most of the people that a 90-year-old with 4 years of education is going to interact with will be younger. This is the interaction of population and distance, just like George Zipf said in the 1950s, but it applies to a space that is really only about social characteristics, not geography. We can think about this when it comes to racial and ethnic categories in the United States. There's a University X that I used to teach at. I won't name it, but I asked its undergraduates to describe the people that they discussed important matters with, using that General Social Survey network tie generating question. I also went to the Office of Admissions and I said, well, okay, how many people at this University X, which was in the woods, okay, separated from other towns, how many people are in all these different categories? This was not a commuter campus. It was a place where students lived on campus, formed ties on campus. Most of the ties they mentioned were students. 66% at this university were white or Caucasian, 8% black, 4% Hispanic, 13% Asian. You would think if there were randomly forming ties, that therefore it wouldn't matter whether you were white or Caucasian. You'd have 66% of your ties be white or Caucasian. If you're black or African American, 66% of your ties would be white or Caucasian. If you're Asian American, 66% of your ties would be white or Caucasian. And only 13% would be Asian or Asian American, because that's the number of people in the community. That's what we'd expect by chance, right? This is what really happens. Remember we talked about the diagonal last week? Look at the diagonal. Okay, this is a description of the percent of whites and Caucasians, okay, who said their alter, their network contact, was also white and Caucasian. Not 66%, 83%. For blacks, African Americans on campus, it wasn't 66% who said that their network contact was Black or African American. 88% of their contacts were Black or African American. For Asian Americans and Hispanic Americans, on the other hand, there's a significant amount of association with white students, indicating that racial homophily is not as strong. Although in each case the diagonal is bigger than what you would expect by chance, what we find at University X is a consistent racial ethnic homophily, especially when it comes to white students and Black or African American students. It's a socially segregated campus. Let's move in our consideration to a different kind of pattern, the ripple effect of a disaster. Bernard, Kilworth, Johnson, Shelley, and McCarty were asked by a newspaper reporter shortly after the attacks of September 11, 2001, how many people knew somebody who was killed on September 11? And how many people knew somebody who knew someone who was killed? Okay. That's an idea about network distance. If you know somebody who was in the event, the attack of September 11th, and was killed, then you have a network distance of 1 from that person. If you know somebody who knows somebody who was in the attack and suffered from it, then that's a network distance of 1 tie, 2 ties. How many of you out there know someone who was killed in the attacks of September 11? How many of you know somebody who knows somebody who was killed in the attacks of September 11? How does that make you feel? Some of you may not remember the attacks of 2001 so vividly. You might have been younger, but many of you were of age. Think about how you felt. Think about what we did. What kind of conversations did we have? Well, we asked ourselves, did I know anybody who was in that attack? And then we asked our friends and our family members, did you know anyone? We were trying to find out if there was a connection to the event. These were conversations that happened all over the place, all over the country. And a lot of people found that they did. Many found that they knew somebody who had died in the attacks of September 11, and a lot of people said, I know, my aunt was telling me her brother was killed. Or my cousin's co-worker, his boss, was in the tower that day. It created this sense of connection to the event, which created this wave of national feeling, which many of you remember. How common was that? How likely is it that we are going to have a connection to an event like that? That's what Bernard, Kilworth, Johnson, Shelley, and McCarty are talking about. They say all you need to know are a few things. You have to know the size of the event, the number of people that were in the event that happened. You have to know the size of the population around you, like the size of the country within which the event happens. You have to know how many people a typical person knows. Bernard et al. Go on and they talk about all the standards by which you talk about knowing. For them, knowing a tie means you know them by face or by name. You've seen them in the last year. You could call them up. And they find over and over again about 290 people. You know, are acquainted with about 290 people on average. There's a lead-in factor, which is the problem that, sure, there may be, you and I may each know 290 people, and maybe we're both in an event, but some of the people that you know are also some of the people that I know. And if we count them twice, then that's overcounting the number of people who know us because we were in the event. So they've actually studied how much overlap there is, and in turn, if you want to control for that, you just divide by 1.6, and that takes care of the problem. If you know that, you can know the total number of people who were in E, the event. And if you go further out and treat the number of people who knew people who were in the event, right? The knowing group is a new event, and you can go out. It's like another ripple. It's heading out from the original event to a new event, which is the set of people who know, and you can ask, did you know somebody who knew about the event, or knew someone who was in the event? Okay, and that's N2, the number of people who know people who were in that event E, at a network distance of 2. You can calculate your own ripple effects for any event, and you can do it using a Microsoft Excel spreadsheet. I'm going to show you how. The first thing to do is start up Microsoft Excel. Everyone has access to this program in your computer labs. Most of you on your own computers at home. The first thing you have to do is name an event. You simply go to a cell, you type up a label, event, and then you name an event. It could be anything. It could be went to a party, a particular party with 40 people in it. Okay? Well, that particular party has people in it, and those people know people. How many people? We know from Bernard et al. That you'll be acquainted with 290. We know what a lead-in factor is, that lambda thing, which accounts for the fact that 2 people at a party are going to know some of the same people. We have to divide by a little bit to take care of that. Then we can write in a formula for our N1, the number of people who know people in the event. The formula you accomplish by hitting the equals sign, which says, hey, we're going to do a calculation. And then what do we do for our calculation? We're going to calculate the number of people went to the party. We are going to put that in parentheses with multiplying times C10, the average network size. That's going to give us 40 times 90 divided by 1.6 to account for the fact that some of us know each other. The number of people who knew people who were in the party, 7,250. Now you can create a new question with N1 as your event. How many people know somebody who knew somebody who's in a party? Well, it turns out that number gets really big really quickly. Look at that ripple effect. From a party of 440, if there are 290 people known by each of the 440 people, and some of those people are known by each other, even then, 7,250 people can know about that party. And 1,314,063 people, if we now do E10 times C10, that degree, that average network size divided by lead-in. Wow, that's the number of people. 1.3 million people know somebody who knows someone who is in the party. Well, if we have a 311 million people country, that means, okay, not too many people are going to be known. Let's see, that's 2.33 times 10 to the negative 5. It's not that many people. It's about 0.002% of the American public are going to know someone who was in the party. 0.004% of the, I thought so. Yes, 0.4% of the American population is going to know someone who knows someone who was at your little party. That's not bad for a party of 40 people. Keep that in mind the next time you have a party. You can do that to replicate Moody's results about how many people in the Middle East, with a population of 547 million people, knew someone who was killed by U.S. forces. That's 7.5 million of them. If we talk about acquaintances and we use a low estimate. 11.4 if we use our high estimate of how many people are acquainted with other people. That's 1 or 2 out of 100 people in the Middle East know someone who was killed by U.S. forces. That's going to say something. 100% if we assume that each person knows 192 or 290 people. 100% of the Middle East knows someone who was killed by U.S. forces. This goes a long way to explaining politics of resentment in the Middle East. Just as we can take this similar numbers and we can talk about the effect of, in the United States, people reacting to the attacks of September 11. Why do we all feel connected? Because we're not that distant in network terms from the event. Most of us know somebody who knows someone who died that day. We could do it with small numbers too, like the fact there are 54 people who've been killed by lightning each year in the United States. That means that there are 9,700 people who were killed by lightning. 1.7 million people who know people who were killed by lightning in a particular year. The percentages, therefore, are not great. 0.003% of the American public for distance 1 and 0.5% for distance 2. I put in some question marks here. If you're interested, I'd like you to go try this at home. I'd like you to think about events that have happened that are important to you. See if you can start up a spreadsheet and follow my example and try to calculate your own ripple effects of the events that matter to you.